Assalamualaikum warahmatullahi wabarakatuh. I am the representative of Group D for the Signals and Systems project. First of all, this video is made to explain on the question that have been given to us. That is question 3 in part B. The question asks us to make a video of explanation of the question 3 from A to C. So there is two parts of this video. The first part is on the explanation of the theoretical of the question, and the second part is the explanation on the Matlab code that we use to generate the output of the question. So let me move on to the theoretical explanation. Okay, so here is question 3A. The question asks us to compute and plot the HT from the HW. First of all, we need to know that HW here is in the frequency domain, while the question asks us to make the impulse response in HT, that is in time domain. So we want to make something from frequency domain F to the time domain T. So in this process, what we need to do is we have to use the inverse Fourier transform from this HW to HT, and we will get the answer. So here it will be inverse Fourier transform. That is, we change from the HW that is in the frequency domain to the HT that is in time domain by inverse the Fourier transform to get the time domain. Okay, that is the theoretical explanation for question A. Now we move to question B. In question B, the question asks to compute the output response YT when the input response XT is given by XT equal to sin 5t over pi. And it is from negative infinite, t is from negative infinite to infinite. So what we need to do is we need to plot xt and yt. So here is the theoretical explanation of this question. First of all, we can see that the xt, we have to know the value of xt. That is xt equal to sin 5t over pi. So what we need to do is we have to change this to x omega that is in the frequency domain. By use, when we change from time domain to frequency domain, what we need to do is we need to do Fourier transform. So after this is the first step. The second one is, so here is the second one. The second one, if we need to use the value of x omega and the value of h omega to make a convolution of both of these, and we will get y omega. And from this y omega, we can see here this one is in the frequency domain. So we need to change it to yt that is in the time domain. So what we need to do here is we need to change the frequency domain to time domain. So we use inverse Fourier transform here, and we will get the yt. Okay, that's it for question B. And about how to compute and plot the output response YT when the input response XT is the periodic signal shown here. So first we have to analyze this graph. And we can see that this graph have the repeated same shape here. The signal is repeated, so it is a periodic step signal. Okay, first, if we want to calculate this theoretically, we have to know that we have to use Fourier series, not Fourier transform, because of the repeating signal from the negative infinite to the infinite. It repeat. You can see that it always repeat the same signal. So first of all, we have to know the fx of this. We calculate the fx first. It is not we calculate. It is we have to identify the fx where it is 1 or 0 at a certain value. The value here. Here it is 1 from here to here. And from here to here, it will be 0. So we have to make a formula, a function from this. Then we have to use the Fourier series formula. That is fx equal to a naught over 2 plus summation of an cos n pi n pi x over 2 plus bn sine nx over 2. So after we use this Fourier series formula, we have to calculate each of the a naught, an, and bn by the formula from the theory. After that, we can just substitute here, and we will get the answer. And after we get the answer of this, we just have to plot it just like what the question asks. Okay, next we will move to the Matlab code. Okay, first we will see the overall. So here is the overall code for this question, and here is the result. First we see the SYMS. This is to assign the variable for this calculation, and you can see UW equal to heaviside W. We use this to assign the heaviside of the function because we have 1 and 0, so it is a unit step function, so we use U. After that, HW will assign with the formula, and HT here, the output of this calculation. We use inverse Fourier to get the HT, and then here F print F. Here is we want to make an output that is the same as this. There is impulse response HT equal and this. Okay, so here you can see here the command, and here is the output. After that, display HT. Display HT, basically ask the computer, the processor, to output to display the output of HT that is here, the output of the calculation at the bottom of impulse response, but in this I just move it up. After that, fplot tht, this is for the graph, and x label t, you can see x label t, and y label ht here, and y label amplitude. So basically from this to this, it is for the graph. Okay, so after that, just press enter in the Matlab and it will create the output of here. The calculation, the result of the calculation is just like the value here. And for the graph, it will the Matlab will auto generate a graph just like this from this coding. So now we move to question B. Here is the code that our group use for this question. Okay, first you can see this is to clear the previous calculation, and here just like question A, it used to assign the variable and then here is the unit step, because we have unit step function, and HW just like what is the previous question, to give the HW the value that was stated in the question. HT is the inverse Fourier transform. There is it is also the calculate what we need to calculate to get the xt and yt. After that, you can see here, given the xt, given the value of xt and sw, the Fourier transform of xt, yw, where we multiply the convolution of hw and sw. Yt here is the result that we need, and it is the inverse Fourier from the y omega here. After that, the system will print output response, will print the script here, and for this, and it will display the value of it here. And for this, you can see is for the output that is we need to plot. Basically is a graph. Okay, you can see here that this one is new for us, subplot. Okay, the function here is used to divide the figure to grid and axis here. And the other, just like question 3a, the label of x, the label of y, the title of the graph. So it will be two graphs, the first one and the second one. Next, we move to the result of this. You can see this is what we print, the output response, and this is our yt, and this is the first graph, the first one, and this is the second one. The first one is the xt graph and the second one is yt graph. Both of these graphs were generated by Matlab by using the code that we use, that I just showed just now. Okay, so the last question, that is 3c. So here is the code. It's quite complicated because it's not the same as before, since the question before we use Fourier transform and now we move to Fourier series. So we start with this since, okay, so here is the first part. The first part is to define the Fourier coefficients as below. So, and the number, the ratio, the n number of this is we use 100, and here is an, bn, the an, bn, and a naught. These three is we assign the theoretical calculation to this coding, where we need to calculate the a naught, an, and bn. And here is the period t, and here is the w naught. Sorry. Okay, now we move to the second part. That is reconstructions of the signal, where ts, t over 20, that is the sampling time for reconstructions, and t is the time for this. And the next part is define n as follow. That is just like what I said before, n equal to 100. And this we assign the value of pi and k. And you can see here is the calculation, and the calculation from here to here. This is all the calculation, just like what we need to do. Basically, what we need to do if we do a by hand calculation, we just move it by using the same formula, and we just assign it as a variable here. So after that, we move to the next part, that is filter, the filter output. This is used to define the value of omega naught, and this is assigned this 1, 2, 3. This coding is used to assign the pi and k value, and here all of here is the calculation that the Matlab will perform to create the output of this for the series. Okay, and we see the result. The result of this coding, it will generate two graphs. That is, the first graph is the Fourier series approximation with n100 and yt with n100. By using all this graph, this is the output of the calculation that was performed by the Matlab just now. And this these two graph is basically is the same as what we do by hand calculation. So that's all from our group. Thank you.